give you an opportunity to join me. So hi, everyone. This is Julianne de Lorenz and Elizabeth Millsaps, and we're going to be giving you a demonstration illustration of the OLIS SpectralWorks software working today with our circular dichroism version. So Elizabeth is at the instrument. She has a sample in place. I'm in my office, and right at the moment, we're in what looks to be the live display mode, Elizabeth.
Yes, so when we first start up the instrument, after it has finished initializing and it's gone into idle mode, that means, okay, the instrument is ready to be used for collecting data. The first thing we want to do on the live display tab is to make sure that our settings are set up for the experiment we want to run, for the sample we are wanting to look at.
Right, and at this point, I see that your last experiment must have been done scanning from 320 to 250.
That is correct, and that is actually what I'm going to be doing again, but just to kind of show how it's being done. If you want to change the scan region, let's say you want to go from 350 to 190 nanometers, for example, you can do so. You will see that the scan range would change from 190 to 189 depending on the number of increments that are selected. So if I wanted to go to 190, then that's going to have to be, of course, I picked something that I can't figure out, 170 nanometers. I think I got that right.
Right, and at this point, your x-axis also changed on your graphic display to correspond with the new range that you just established.
Correct.
Cool.
And yeah, but I'm going to go back to the what I had before, which is for our standard sulfonic acid, which has a big peak at 290.5. So I'm going to go back to 320 to 250, and now it's, of course, will recalculate the ending scan range. So I will type that back in.
Great.
I'm going to leave my integration time at 0.5 seconds for the purpose of running this, but that's also a field which you go in and change to whatever you need to do, shorter or longer.
And at this point, you don't have the little box tag next to digital filter, so we're going to be seeing the raw data come in that have not yet been smoothed.
That is correct. That's what we're going to do. I'm also set up, you have a lot of these settings, not a lot of these settings, some of the settings on this screen we're on are dependent on settings that are selected on the operational modes tab of the software. So for example, I'm set to fixed bandwidth mode, which is typical for the instrument that we are using, which is a carry-based instrument. But this can be changed, and I can go there and show you already where that is being done. It's in the scan mode, and you have options to set to fixing your high volts. You can fix your slits, you can fix everything. But I'm going to leave it at fixed bandwidth, which will adjust the high volts as we're scanning, and depending on the light level, it will increase or lower the.
So the spectral resolution across your entire span will stay the same. What will vary based on the light level is the high voltage reading, the gain setting on the detector.
That is correct.
Okay.
And I'm in scan mode, and then obviously because we're doing circular dichroism, I have the data reduction mode for circular dichroism selected.
Right. While we're on the screen, Elizabeth, yeah, I think that those are kind of self-explanatory, but the Lambda Time script, is that something that we should look at? Is that?
No, not in this case.
Not in this illustration. Okay,
no.
Good deal.
I won't worry about it. In the lower left-hand corner, however, on the top part, is something of interest, and that's to run it at either a constant integration time or to run it with an integration time as a function of high volts, where it will adjust your integration time depending on what your light level is. And so when it gets harder down at the lower region, like closer to 220 to 200, it's going to increase the time per point that it's taken to collect the data for you to get.
Unless you force it to not change the time, in which case you will anticipate getting higher noise in the regions where there's less light.
Absolutely. Absolutely. And yes, and we can go into more details on the integration as kind of as functional high volts, because there are also user-defined settings in the software where you can set the max time that it can go to. There is really no max time, but it gets a little bit ridiculous if you set it too high. So, but it's a user-defined time.
Okay.
All right. So now, I don't know, did you want me to go through the other tabs?
No, let's just go ahead, and since you've got a sample in place, let's watch some data collection, because if you're not changing your experiment a lot from one experiment to the other, most of these settings you're not going to handle. You're going to be adjusting your span, your range, and maybe you're going to change your integration time. Maybe you're going to change a few things, but by and large, there's not a lot of settings that you are required to change between experiments, particularly if you're working with a similar protein or whatnot.
Correct.
Yeah. So at this point, we're seeing a single scan on a single graphic. It starts at the higher wavelengths and it's going to go down towards the lower wavelengths. We did set up the 2 nanometer band pass, so we're collecting a datum every 2 nanometers. We had set the time, the integration time is ½ a second, so we're spending a ½ a second at each of these every other wavelengths. And again, we're not doing any smoothing at this point. Obviously, there's a lot of light in this region, so the data are going to be nice and pretty. Yeah, so indeed, those 2 values that are changing. What are we looking at here?
I'm sorry.
The PMT and the CD values that are changing?
The PMT is the signal, and you can look at it in a different way too. You can see the signal as it's moving around depending on the light that's reaching the detector. And it will, the same thing you see on the right-hand graph is what is being presented to you at the PMT portion of the software.
Okay.
And then the CD is the calculated circular dichroism signal that
so that's actually what's being plotted in the left-hand graphic.
Correct.
Okay.
So whatever this was at each individual wavelength, it was presenting the CD in the data collection window. So when the data has finished posting or finished collecting, you get prompted to save it over to GlobalWorks, and this is what you get.
Terrific. Okay, well, let's just call that a day for this demonstration. Thank you so very much.